To meet the challenges of the 21st century, buildings must be efficient, adaptable, and embrace new technologies. As architects, it is our duty to find new ways to minimize impact on the world. One Central Tower combines two of my greatest passions in architecture: sustainability and technology. It focuses on exploring ways of using readily available computational techniques to find inspiration to create a building which engages with people. It also pushes the boundaries of our profession by exploring new technologies and materials. Focusing on the balance between intuition, systematic design, and most importantly, the continuous dialogue between design and technology is one of the greatest achievements of this design. One Central Tower is based on topology optimization, where materials are reduced to the absolute minimum as a sustainable and structural strategy. This creatively integrates innovative geometries with technology and sustainability. Understanding the user's needs creates high-quality experiential architecture, which has a positive impact on people's lives, both in the present and the future. When combined with high response to context, it makes architecture unique for its location, enhancing people's experience of space. Located at the heart of Cardiff, One Central Tower will be the new gateway to the capital of Wales. Serving an average of 14 million travellers each year, the tower is of mixed use and responds to the needs of a vibrant, rapidly developing capital city. Examining the spatial configuration of conventional mixed-use towers, it was evident that they tend to be organized in a striated and very linear manner. Learning from the organization of Cardiff as a city and adapting it in a vertical arrangement would help to create a truly mixed-use tower. This was examined by arranging a series of functions within a prescribed volume using three-dimensional space syntax. Using evolutionary structural optimization algorithms, the spatial organization of the functions would in turn inform the resultant optimized geometry of the prescribed volume. This would create its internal structure. The geometry of the structure was controlled by repositioning the functions, altering the size of their applied vertical loads, and introducing voids in the prescribed volume. The volume was also tested for horizontal loads, which indicated the need for an exoskeleton. Interpreting these results, the internal structure would replace a traditional post and beam construction, while the load points would be used as positioners for functions within the tower. The proposed structural solution is 28% more efficient than the conventional post and beam construction, enhancing it as an environmental approach. Understanding the optimization results and observing their geometries would then inform the architectural form finding. The tower is proposed to be constructed using 3D printed timber, which is a novel material using lignin, timber dust, and coconut fibers, a mix inspired by glass fiber reinforced concrete. 3D printed technology would be complemented by CNC milled floor beams, resulting in an automated construction process. This would reduce human error, aid in geometric complexity of the construction, and reduce construction time and cost. In designing the tower, the initial volume was derived through solar optimization. The volume is an optimized geometry which maximizes solar radiation on the surface as an environmental strategy to reduce heating requirements of the tower. The required functions were defined as points and interconnected. Using three-dimensional space syntax, the distance between the points was optimized both horizontally and vertically. The optimized points were then used to position the vertical loads in the optimization algorithm. They also signified the initial location that the functions would occupy when converted to volumes. Horizontal loads were then applied. These were derived through CFD analysis on the surface of the geometry. Using the vertical and horizontal loads in the structural optimization definition derived the internal structure of the tower. Combined with an exoskeleton, they make up the structural system of the tower. Examining the geometry of the internal structure, a network of voids was observed. By subtracting the void network from the solar optimized geometry, enhanced solar gain within the tower by allowing a deeper penetration of light. The voids caused an increase on the surface pressure of the tower, which could be used to harvest aeroelastic energy by introducing oscillators such as piezoelectric flags. The optimized function points used in the three-dimensional space syntax define the position of the functions when converted to volumes. This was achieved by simulating the functions as balloons of controlled volume. The balloons would interact with each other, deforming within a boundary geometry and blending together to create the organizational concept of the tower. The relationship between the tower and the ground was gracefully resolved by designing a podium. The podium is sensitive to its context by taking into consideration the height of the surrounding buildings. Together with a solar envelope analysis, the podium's geometry was derived. The podium reintroduces the Cardiff Central bus station, which was removed in 2015 with the redevelopment of One Central Square. The podium is, however, kept at conceptual level as the design focus is on the tower. 3 indicative levels of different characteristics have been examined within the tower. The first is the ground floor, which includes a lift lobby connecting to all functions of the tower. The second is level 5, which includes a central atrium, and the third is level 20, which does not include an atrium. Levels 5 and 20 include 3 different functions each. All floors include fire escapes, which are introduced as 3 continuous ovals, which are attached to the exterior of the building. The structure of the floor is made of glulam beams, which have been optimized in structural depth and are connected to the 3D printed structure on one side and the exoskeleton on the other. Vertical circulation is split into 2 categories. The first is the inter-function connection and comprises of inclined lifts moving within the internal structure. This is similar to how a tree works, where water and gas travel inside the bark through tube-like structures known as the xylem and phloem. Similarly, these lifts transport people from the lobby to the lowermost level of each function. The intra-function connection lifts consist of scenic lifts and stairs, allowing for complete transparency connecting the people to the function. The tower is designed using the latest technologies, including computational tools and virtual reality. The tower aims to revolutionize architectural form finding as we currently know it, to create a tower which is both innovative, sustainable, and human-centered.